We can use multivariate analysis to detect confounding in our data. So this table is from a research study that was actually published. And in this research study, what we looked at was the relationship between race, ethnicity as our independent variable and whether or not someone was denied health or life insurance. That was our outcome variable. So we looked at this data and presented it in this table using a logistic regression model that included an unadjusted logistic regression. Those results are displayed here. And then we also ran an adjusted logistic regression. Those results are displayed here. And in terms of what we controlled for, the variables that we controlled for as potential confounders, these are listed here. So we controlled for all of these variables in this table, as well as the year of the survey that was completed. So the first thing we did is we ran an unadjusted logistic regression, basically looking at the relationship just between race, ethnicity, and the denial of health or life insurance. And when we ran that regression, we got these results. So our exposed category in this example would be people who identify as white, non-Hispanic, and the other groups that we're comparing that to include Black, non-Hispanic, other non-Hispanic, and Hispanic. And what we see is that compared to those who are white, people who identify as Black, non-Hispanic were 3 times more likely to be denied health or life insurance, compared again to those who are white, non-Hispanic. Those who are other non-Hispanic, they were 2.56 times as likely to be denied health or life insurance compared to this white non-Hispanic group. And then for those who identify as Hispanic, they were 2.77 times as likely to be denied health or life insurance compared to those who are white non-Hispanic. These results were just looking at the crude relationship between the exposure variable and the outcome variable. In this adjusted logistic regression, we are running a logistic regression, but in that model, besides our independent and dependent variable, we are throwing in variables that we think might potentially confound the relationship between race, ethnicity, and the denial of health or life insurance. So in this adjusted column right here, what we're reporting is the relationship between race, ethnicity, and the denial of health or life insurance after adjusting for things like sex, income, employment, and the survey year. So after adjusting for those variables, what we see is that we have an adjusted odds ratio of 3.0 for those who identify as Black, non-Hispanic compared to those who are white. In this adjusted analysis, people who identified as other non-Hispanic, they were 2.16 times as likely to be denied health or life insurance, and those who were Hispanic were 2.13 times as likely to be denied health or life insurance compared to those who were white or non-Hispanic. Now, to determine the presence of confounding, whether these potential confounders actually caused confounding and confounded the relationship between race, ethnicity, and the denial of health or life insurance, we would need to use that 10% change rule. So we would calculate the difference between the crude odds ratio, which is these odds ratios, and the adjusted odds ratios, which are these odds ratios, divided by the adjusted odds ratios. So I would do that for each of the comparison groups. So I'll start by looking at those who identify as Black, non-Hispanic, and I would take 3.08 minus 3.0 divided by 3.0 times 100. This percent change is much less than 10%, so I would conclude that there isn't confounding for that specific level of race ethnicity. I would then go on to looking at other non-Hispanic, and if I compare 2.56 to 2.16, if I calculate that percent change by taking 2.56 minus 2.16 and then dividing that by 2.16, I get a percent change that's just actually a little over 18%. And then if I look at those who are Hispanic and I compare 2.77 to 2.13, again using that formula of 2.77 minus 2.13 divided by 2.13, I get a percent change that's a little over 30%. So because I see that in these two groups here, this other non-Hispanic and Hispanic, the percent change from this unadjusted odds ratio or my crude odds ratio compared to these odds ratios, it's more than 10%, I would conclude that these variables that I controlled for, sex, income, employment, and survey year, that these are indeed confounders in the relationship between race, ethnicity, and the denial of health or life insurance. So given that these variables do confound this relationship, what I need to report for my results is the adjusted measures of association. These are going to be the more valid measures in terms of that estimate for the relationship between race, ethnicity.